Today, we're going to talk about a parabola. What exactly is the set of points that fit on a parabola, and how do you derive the equation of a parabola? So, let us draw a parabola, or at least attempt to draw one. Here is a parabola, and not a nice one, but it'll do. It has a focus point, and we'll say the focus is at 0, k. That means from the vertex to the focus is k units. If we go k units in the opposite direction, we will arrive at negative k. The directrix is this line. In this case, y equals negative k. Now, what is the definition of a parabola? How does this point, x comma y, get to be on the parabola? But let me just put that point somewhere else. Let me put it up here. And the question is, how does that point and any other point of the parabola come to be there? And the answer is very simple. If the distance from the focus to the point is equal to the distance from the point to the directrix at a right angle. It's the set of points that are equidistant from the focus and the line y equal negative k. So let's do that. What is the distance of this red line? Well, it's x minus the 0 squared plus y minus the k squared square root. And it's supposed to equal to this length. Well, if this point right here is x comma y, like we've been saying, then that height is y, and that height is k, and when you add them, you get y plus k. Now, let's square both sides. Remember that x minus 0 is just x. So when we square it, we'll get x squared plus y minus k squared is equal to the other side squared. Let me bring this term to the other side. So I have x squared is equal to one thing squared plus, minus another thing being squared. That is, I have the difference of squares. How do you factor the difference of squares? Well, first, the left side is still x. You factor the difference of squares by adding the two terms, and you'll get 2y. And then by subtracting the two terms, then you'll get 2k. And x squared is equal to 4ky. That is the equation of a parabola. Some people may say dividing both sides by 4k is that it's 1 over 4k times x squared. Both are right. That is the general equation. These are the general equations of parabolas centered at the origin and whose focus is at 0k, or the directrix is at y equal negative k. They come as a pair. If I tell you the center is at the origin right here, and I tell you y equals negative k, you should know, oh, the focus must be at 0, comma, positive k. This completes the derivation of parabola. So I want to talk about one other thing. Parabola has very interesting property. If you say put a light bulb at the focus, and you don't aim the light bulb outside, you don't aim it that way. You aim it interior, inside. Well, this piece, that light beam, will go straight out. The light beam from the foci that hits the parabola there will go straight out. It hits it here, it'll go straight out. If it went straight down, well, it's going to go straight back and hit their light bulb. But if the light bulb wasn't there, it'd go straight out. Here, straight out. Straight out, straight out. Now, if you were to take a parabola, put down the line of symmetry. If you were to rotate this, what you would get would be like a bowl shape. And here's the foci, by the way. You would get a bowl shape. And it's called a paraboloid. And now, many years ago, when they used to make cars, this is how they made the headlights. They would put the light bulb right here. But they would aim it this way. I was kind of surprised when my physics teacher told me that. They would aim it that way. And the reason is every beam of light, assuming they made their paraboloid perfect and they found the exact foci, then every beam of light would go straight out, which I thought was pretty neat. So it actually had real life properties that were used to make headlight beams, and they worked the best that they could. Every beam of light went straight out, as opposed to maybe this beam going that way, or this beam going that way, and this beam going that way. More chaotic. Now, one last thing I want to mention is, if you have a flashlight, okay, here's the bulb, and some flashlights, you can rotate the top. And what happened is, maybe when you rotate it to one position, the light only has that angle. And then you rotate the head some more. I'm trying to draw the exact same like flashlight. And now, so you rotate it, and now all of a sudden the spread is a lot wider. And then you rotate it more, or you rotate it a lot the other way, and the spread is even smaller. What's happening is that they're playing games with that cone shape in there. They're playing games with the cone. They're making the cone closer to the bulb, further away from the bulb. If you were to change these distances, if you were to change those distances, it's going where that's the cone, you're gonna change how much of a spread you have. Okay, but it's gonna be more chaotic. Maybe this beam won't go like that because That's not the foci. Maybe they moved the bulb. Maybe I'm wrong. But whether they moved the bulb or they moved the cone, it doesn't matter. It's the same as, say, moving the bulb. The bulb is no longer after focus. And when the bulb is not after focus, it can play games with the spread. Okay, this completes the video on a parabola.